derivation graph as of January 6th, 2025. I have a few derivations and other entries here in the graph already. I'm going to delete those just so that I can start fresh. I could have uploaded some content from an existing database, but for now I'm going to do everything manually. There's some timing information down here on the front page. Alright, so let's delete everything and start fresh. Alright, now we've got no derivations and no inference rules, so if I look at them, I see there are no derivations, so I just have to add something. So let's make a new derivation. We're going to provide a reference there. These black boxes popping up are because I've previously entered this text and it's remembering it in the browser history, but you'd have to type it in manually if you don't already have that text. So we're going to create a new derivation. There are no inference rules currently, which is going to be a problem, and so we're going to have to create a new inference rule. I'm going to click on this link in a new tab so that I can come back to this open page later and refresh the browser. So we'll come back here after having created an inference rule. Let's make a new inference rule. We'll call it add x to both sides. Again, this is text I've already typed in before. I'm going to set the number of inputs, outputs, and feeds. I'll then add that inference rule. I will add two more, the initial and final expression sort of inference rules. So let's do that quickly. I'm going to declare initial expression. We'll call that one this one. And that one's going to have an output but no input. And then the same thing for the final. And we'll have an output, let's see, it'll be an input but no output. Alright, so now I've got some inference rules there. We can close this tab and go back to the part where we're adding an inference rule. Now we can refresh this page and we'll see that there are a couple options available. So let's click on Declare Initial Expression. Now there are currently no expressions available to select from, and so I'm going to add a new expression in a new tab. So I'll click on this one and I'll open that window, open that tab rather. And here we're going to be prompted for the left and right hand sides. There's no scalar values you have to use, so I'm going to open that in a new tab. And then we'll also need to provide our operations and relations because we haven't done those before. So let's make some symbols. We'll call this A, give it a name and a description, and then some text there. Those are all optional. Here, these variables, these parameters rather, can be set. We're just going to leave them as is for now. And then the dimensions are also editable, but we're going to leave those as defaults also. While we're here, I'm going to add two more symbols. So we'll add B and C, just so we can use those later. Nothing too fancy here. And then we're going to leave those as dimensionless variables. And then we'll add C. This is C. And take all the defaults again. So here's our three scalar values we provided. And we're done with this tab. So let's go to the next step, which is creating an operation. Again, this was a tab that I opened previously. We're going to add plus sign. It requires two operators as binary. And then we're going to call this add. And just to show off comparison with another one, we'll make another operation. I'm going to have this one be integral. And again, I can preview that. This one's going to take two arguments, and then we'll call this integral integration. So now we can, just as a demonstration of the filtering in these tables, we can do a plus sign, and that's only going to show the rows with the plus in it. And then over here, if I search for int, that's going to dynamically render just the rows that are matching up. So we're done with our operations. Let's close this tab. And then our relations are going to be something like an equal sign. I'm going to call this one equals. And then just for comparison, we'll add another one. Call this one less than or equal to. That one renders in LaTeX. And we'll call this that. Okay, so now we've got relations. We'll close this tab. We'll go back to the part where we're going to enter an expression to be used. And now let's hit refresh on this tab. And you'll see this popped into existence as a thing that we had just entered. Now we're going to say that A equals B is our expression. And then we can preview that if we want, both sides. We'll call this some text there. Okay, so now we've entered A equals B as an expression. We want to say that A and that B are the ones that we've identified as scalar variables before. As this A and B is what we entered. And so we're going to associate that with the expression. And once we've done that, we can use that in our SymPy representation. All right, so now the consequence of having that expression associated with these variables and using the SymPy representation is that we can validate that the dimensionality of this expression is consistent. A is dimensionless, B is dimensionless, they're the same thing. So we're going to add another expression here. Let's call it A plus C, B plus C. Again, nothing too fancy there. Again, we have to do this association of the plus sign that I was referring to in the expression is the same operator that I have in the database already. This is trying to guess the SymPy. It's not quite correct because this would be the word add instead of a plus sign, but we'll accept it for now. All right, so the dimensionality of the left-hand side and the right-hand side are again as expected. So I think we're done with the expressions for now. Let's close this tab and go back to the part where we're making a derivation dependent on some expressions. So now I can refresh this page, and this drop-down box populates from the database, and we're going to have the output of the declare initial expression be A equals B. This will be some So we've got a derivation with a single step. It's got a reference link, and it's got all the information about the step here. The validation is not relevant for this declare initial expression, so that's what's happening there. We see a graph res representation and a D3JS representation. So these are sort of like dynamically sort of able to be zooming in and out, that sort of thing. All right, let's add another step to this derivation. So here I have these different options available for my inference rules. Let's go with the add x to both sides. This inference rule requires 3 arguments, and so one of them is the feed, but we didn't make any feeds yet. So let's open a new tab and go to that feed menu. This is just going to, we're going to promote an existing variable here, C, into a feed variable. So let's close this now that we're done with the feeds. And now if I hit refresh on this page, C is now an available feed. And I'm going to change this to the resulting equation for the output. I'm going to add the step. And because A, B, C, and plus were already recognized symbols, I don't need to do anything extra for associating with the SymPy. So here, the inference rule is add x to both sides. That's a step that we could check, but I haven't gotten around to doing that yet, so it says it's not enabled yet. And then the graph is sort of as you expect it, declare initial expression. You've got an inference rule here with a feed, graph is. So let's complete this with one more step. And declare final expression. There, we're just going to select from the existing. There are no feeds or outputs, and we'll add that step. All right, so now we've got an initial expression. We do an operation, we get a result. And let's check out what the text file looks like for that. Oh, by the way, this is your dynamic D3.js representation. Well, let's look at the text file. All right, so this is all the text that is generated from the inference rules that we already declared in the database. And then here are the expressions in our database. Let's go back and see if we can generate the PDF for that file, for that derivation. All right, so we have a PDF. We have an expression that we're starting with. This is the text that we entered in the web form. And then this is the inference rule text, and then the output. And then the inference rule here that we're using is add something to both sides, where C is the feed, and that's the final expression. So that's the entire derivation rendered in PDF based on input that we made from the web form. As our last step that we'll get to, once we've got this text in the database, we can query the graph using Cypher, because it's a Neo4j backend. So let's go there. On this page, there's a set of pre-computed, pre-specified Cypher queries that we can click on, or in this box here, you can make your own. So let's start with looking at the schema for the nodes. We'll click on that, and it shows us what the different node types are currently in the graph. And we can do the same thing for edge types. So those are all the different edge types in the graph currently. And then, so let's down to, let's say, just the different inference rules. So there's lots of different things that you can do with Cypher queries, and these are just some of the examples. They're not meant to be comprehensive. They're just demonstrations of what you can do, and you can type in your own Cypher query here if you want, as long as the Cypher query is read-only. It does not allow write-based queries currently. So let's look at specific properties for a given derivation. Now it's pre-populated with a derivation ID that already exists, which is why it's able to find this. So this is the same text that we typed in here, and this is the same reference. The other thing you can ask for, you can do a regular expression in the text property. Here the pre-specified search query doesn't have any actual meaning, so let's look for here a property like descript. We'll query the graph. Okay, so there's a node property that contains the word description in the text for the property.